All right. So, Crinkle, you done? All right. Okay, so what we did was we did the bell work here. Just look at it. And then you missed all my stuff about investing in the power of exponential growth. All right. So hopefully you can fill that out. What I did do is change using exponent rules Allison's formula to Beth's. So those that are at home, hopefully you can handle that. Okay, so we're now to this. This is what an exponential looks like. And the point I was making is when we had a geometric sequence where the inputs are discrete, that means I could only plug in, well, we could start with crinkle, crinkle, 0, 1, 2, and so on and so on and so forth. Okay? Then it was fine to have a negative b value or a negative r value. All that happened is the graph oscillated from above to below. Remember? We had a problem like that. Okay, well, now when you have an exponential function and I'm no longer plugging in discrete numbers, I'm plugging in decimals and all the numbers forever and ever, a negative b value can't happen. That graph would shut down. I think I've actually typed in the graphing calculator a negative b value exponential, and the graph is just totally wild, totally crazy because of that oscillating feature and crazy stuff. Okay, so input, say it. Okay, you know what? Wait a minute. You just told me it was a times b raised to the x. It's always going to be in that formula, but I only see a b. What does that mean a is? What is a actually? One times. I didn't tell the other hour that. But my A Bers, we ran into this already, and they got this, and they're like, "Hey, what's A? Is it 0?" Right? Oh my gosh, what's 0 times anything? First of all, nothing. So it's got to be 1. But anyway, input, say it's. What's 2 to the 0 power? 1. What's 2 to the first? Come on. What's 2 to the second? Come on. What's 2 to the third? You're too slow. All right. What's 2 to the negative first? 1/2, not -2. No one said that because you all been trained. 2 to the negative second is what? 1/4. 2 to the negative third, it's 1 over 2 to the third. For those that are struggling out there, this is 1/8. So if you graph this, and we do this with the A-Bers too, just give you a freedom to where you put the X and Y axis in case you get really large Y values. But my largest one I see is 8, so I think this is a reasonable spot for an X axis. And a reasonable spot for a y-axis is close to the middle. I think it might be right in the middle there. 0, 1, 1, 2, 2, 4. Really angers me with my A-Bers that they still can't plug in points. There's something, I don't know what happened to them mathematically. I still have people that just cannot evaluate to save their lives. Thanks for listening. Because it is something that's driving me crazy. This class is so hard. No, it isn't. Whatever happened to you coming into this mathematically is what's making it difficult. So I hope you have no problems with that as well. Hey, by the way, that's annoying when I put 1/8, and then if I put it in -4, I get 1/16, then 1/32. The outputs will never be what, but they'll be close to it. 0. So what do humans do to make that happen or like show that behavior? They draw an asymptote. Those asymptotes don't exist there. You draw it because you're annoyed by this. Okay, how do I show that these numbers go? What's he doing? Okay, those numbers are getting so slow. I'm just worried about the paying attention over there. All right, so small that I get sick of graphing them, so I just draw a boundary. All right, to make that happen. That's what an asymptote is. It's not really there. It's a boundary that we draw. Okay, let's speed this up. 1/2 to the 0 is 1. And then 1/2 to the first, 1/2 to the second, 1/2 to the third. Nice, some are catching up. And then what? Catch up. All right, 1/2 to the negative first. What's that? 2. What's 1/2 to the negative second? Flip and square. If you don't know the flip rule for negative exponents, you're severely and totally, anyone? Behind. Like my 8 years. Trying to get the negative exponent rule. A couple other rules that they just have to memorize. Gotta memorize. Gotta memorize. All right, 0, comma 1, 1, comma, oh, okay, this behavior is happening on this side. And then negative 1, comma 2, negative 2, comma 4, negative 4, comma 8, 2, 3, 4. And then this graph happens like this. So it's a flip over the y-axis, if you want to call it that. I actually kind of could think of it that way. There is a reason. Okay, I'm going to zoom in on this because this is hard to write when this is zoomed out or zoomed in so far. You have no limitations in what you can plug in for x. You can raise a number to any power and get a result. But the range, look at this specific picture, and it's only positives and 0. Okay, that's the only things that we have here. What's wrong? We okay? Did I miss something? Need something? Okay, so I'm on the first one. The graph that is increasing. And there you go. I can put that next, but we're going to do our limits here. This is really why I have to zoom in. What? I don't know what I just said. It was like trying to do a fraction there. X approaches negative infinity. Okay, what happens when x approaches negative infinity? Where does y go to? 0. We should already know that. Now that we see the picture, this should be given. All right. All right, and then the limit of f of x as x approaches infinity. What's that answer? Infinity. Everyone's like a little slow today. Is everyone okay? Tuesday's rough sometimes. Increasing or decreasing this first one? How often is it increasing? Forever. Extreme values? None. There is no max, min, nor point of inflection. It continuously increases. The asymptote is for sure y equals 0. And the intercept in this case is 0, comma 1, the y-intercept, because that's the 0 power rule. All right, and then the only thing that's different is this. You know what? Let's be lazy. That's the same. That's the same. What's different is this decreases. This is the same. And this is the same. The only thing that's different is the end behaviors are flip-flopped. Limit of f of x as x approaches negative infinity. I'll slide this up. I'm on this picture. Oh, inputs, outputs. So that's infinity. Some of my A-Bers have missed every single limit question all year long on every quiz and every test, and I want to cry. I really do. I want to cry. Inputs, say it. And what is that output value? 0. Every single one. It's infuriating. No extreme values. Thanks for listening about my APers. Are you okay? Okay, now general. Now look at what we put here. A times B raised to the X. So we don't have any shifts. So we're going to do that next soon, let's say. I haven't looked ahead. I think maybe tomorrow, but we'll see. And then the range, and we're saying that A is positive, so we're not talking about any flips over the x-axis yet. Just the general A times B raised to the x format. So if there's no shifts, up, down, right, or left, up, down, really, then y equals 0 is for sure what's happening. All right, the function is increasing on its domain when B, so A is always positive. I don't care if A is a fraction, but B's got to be greater than 1. So that's the 2 to the x1. So that's this one, the first one. So look at B's greater than 1, and I get a increasing scenario there. Now be careful, once we start throwing negatives, then things change. And then look at that one. As I went to negative infinity and positive infinity, this happened. Now the way I have to word this is B is between 0 and 1. It could never be negative for exponential functions. It's different than sequences. All right. And then now be careful. What's b to the 0? Doesn't matter what b is. What's b to the 0? What's 1 times a? What's 1 times a? A. So actually, if I throw an a component in there, then the y-intercept is whatever the a value is. So I do have to make a little minor change on that one. Got it? Now, I think we're going to get into this more graphing later. But yeah, we're just going to leave that alone. Okay, now you might recall that Allison's plan started off with earning a penny, 0.01, and her equation could be written as, that's not true. I'm going to change this. Let's do it to, was it Beth, the other one? Because what was Allison's? X what? X what? X minus 1, which is a right shift. Huh? 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 Okay, but I wanted to keep it A times B raised to the X, which was Beth's equation. So just a little minor adjustment. So what does that 0.05 do? What's a multiplier in front of a function always do? Ver, ver, verta, vertigo? I'm afraid of heights. What's the answer? Vertical. Is it a stretch or a shrink? Shrink. Didn't we do this already? Didn't we do the... So, I mean, let's think about it. If I look at this picture, this is 0, 1. If I added that 0.05 in front of that, then it'd be 0, 0.000. Holy smokes. Right? That graph would be like this. And then the growth would not happen for like quite a while. But then eventually, I just made it a straight line, didn't it? And you should yell at me because all lines are, anyone? Straight. That's a redundancy. But anyway, it would be shrunk greatly. Do we need to do jumping jacks or something? You guys are bringing me down. Can you put a smile on your face? Do I have to be dressed as a clown and here's the math? Let's excite the kids so they're all excited during the math lesson. Okay, it's illegal. I can't wear a costume and a mask. I put paint on my face. You know, fun world we live in. Do that one. Okay. Got to entertain the children during, when I went to school for teaching, just teach them the math. Then 2 years later, you got to be an entertainer to keep their attention. So you got to jump around, do hula hoops, and give them prizes. No, I like the prizes thing. Okay, at least wanted you to look at it, read the directions. What's the first one? Is it exponential, linear, or neither? 3, 2, 1, go! Okay, now you know what it should say? It should say linear or quadratic or cubic or quartic or exponential or neither. Why? I think you see the second one. What's the second one? What's the second one? What's the second one? Linear. But what if the first order differences were not equal and the second order differences were? Then what is it? Quadratic. You've already done this in cubic. So we should have thrown that in. What I'm trying to do is you're expanding your world now. So we already did linear, quadratic, cubic, quartic, and further. Fifth order differences are equal. Then it's an x to the fifth. Now we're adding exponential. Why is this exponential? What happens from here to here to here to here to here? What are all of these? How does it change? Equal input values. And then what is my thing happening out here? Okay, I'm just going to sit here. No one's answering. I don't know what's going on. Does this help? What's the answer, kids? Here's the clown. All right. How are these Y's changing? Someone say the word. Multiply by 3. See, Clown Samuelus got the answer out from him. Okay, so now what's the equation? y equals, hey, what's the initial value? This ought to go well. 4. Y. Input, say it. And what's the input value for 4? 0. And then what's r, which I wrote on the thing? 3. And then raised to the what? I guess we'd say x. I guess I should put this as f of x. Oh, 5th hour. Rough times. Okay, the next one we already said was linear. What's our common difference? Plus 0.5 all the way down, right? So if it's linear, it's y equals mx plus b, or we'll change that to f of x. So I'll write f of x. What's m? 0.5. And what's b? The y-intercept. That should be easy. 2. Simple Simon stuff. And then the last one. We almost done here? Okay, what's going on here? Maybe it'd be better to go this way. So it's multiplied by what, though? 1/5. Uh-oh, I gotta. Oh, what was that? A transaction just happened. There's a policeman, too. Would you get a ticket? Nice. Awesome. Okay. All right, so what's my initial value? F of x equals. What's my initial value? 5 Mr. Samuelus. And then what's the r value? 1/5 Mr. Samuelus. Raised to the x. Input, say it. So if I plug in 3, oh no, that was a tough one. 3 to 1/5 to the third power is 1 over 125. Then times 5 just divides 5 into 125, which is 1 over 25. Maybe an easier one would have been -3. Maybe not. -3, 1/5 to the negative third is 5 to the third, which is 125 times 5, which is 625. I always check a couple input outputs because it's supposed to create those numbers. As long as it does create a couple of them, you feel pretty good that that's the right answer. Okay, book assignment, blah, blah, blah. Did I talk about these then? I didn't talk about the chessboard problem, did I? Did I talk about it? But I didn't say, here's the chessboard problem if you want to read it. That goes back to our bell work kind of thing. This is a fable that's well known. Look at how many. So chessboard. First checker on the first square on the chessboard, 1 grain of rice. Then 2, then double it 4, then double it 8. How many grains of rice will you have when you're done? Look at that number. Look at that number. Now, rice is very small, but still that number of rice would probably take over and be as large as the whole world. Or look at what they say, that's more than 2,000 times the annual output production of wheat. So that's the amazing thing about exponential growth. All right, and then the powers that be, that's the other 2 teachers, wanted to shove this at you today. So that's your other sheet of paper that you have. I wanted to break this down a little bit. So yes, this is expanding on. Sorry, lengthy notes today. Yesterday was easy. Should I have stamped today as well? I should have. Darn, I won't. Get on me though about stamping. Okay, how many people have a savings account? Anyone? 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 Nice. How many people invest? Anyone investing right now? Nobody? Nice. Cha-ching. Okay, about the investing, the whole idea of compounding your money. But if you have a savings account, you probably get a crappy interest rate, but you get something. And you probably get statements every month. Nice. When he gets a fumble, when he gets it, you okay? When he gets a statement every month, he's probably getting an interest payment every month. So we're going to use his as an example. This is not simple interest. That's a simple interest. So let's say, you know what? Let's be ridiculous. Let's say he gets 12% interest per year. That's a joke. You probably get 0.1% interest per year. You probably get a ridiculously low percentage amount. But I want to do 12% to make my math easy. If it was simple interest, then this turns into 0.12. Please don't do those silly mistakes. 12%, move the decimal twice, right? So what does the 1 mean? What does the 1 mean? That you're keeping your money and then adding 12% to it. The 1 represents you keep 100% of your money, and then you get 12%. Do you understand? They ask you this later. What does the 1 mean? Like, and that's what it means. I need that there. If I only put a 0.12 in there, then you're losing 88%. You're only getting 12. So if I put $100 in and I only put 0.12 in these parentheses, $100 turns into $12 in 1 year. Is that what you want in an investment? No, because you're losing 80% of your money or 88%. So no, that's why you need that 1 there. But then his thing, he gets 12%. Since he's paid, he doesn't get 12%. Nobody gets that. You only get that if you invest in the stock market and have a decent year. Compounded monthly. Here's what that means. Let's say he puts $100 in. It doesn't mean he gets 12% a month. That's a joke. What he gets is in the first month, month 1, he gets 12% divided by 12, which is what percent? He gets 1% on his money. So what's 1% of 100? What's 1% of 100? 1. But now he has $101. That's what the 1 is in the formula. That's what this 1 is in the formula. Keeping the 100, but then adding that. Now this is how this is different. If he gets 12% in this account over here, at the end of 1 year, he's got $112. Got it? Very simple. You tack on the $12. You get it at the end of the year. Now here's where it gets nuts, but it doesn't really. In month 2, he now has $101, and then he gets tacked on 1%. Could someone take 1% of $101 and tell me what that, or take 1.01 times 101? Nobody's doing it. We're all just sitting. This is 5th hour. This is like rough. This is rough. Oh, back in the day when I was teaching in the 90s, the kids are like, ooh, hurry up, teach. Let me learn. Ooh, I'll help, Mr. Samuelis. Then does anyone know the answer? 34 hands and go, me, pick me. And everyone's just like this. Is there an ad for that? Oh, I have some texts. Did anyone calculate it or no? Are we still sitting here like a bunch of maroons and just staring at each other awkwardly? What what are we supposed to do? We're supposed to take 101 and multiply it by 1.01, tacking on 1% on $101 for the love of 102. What do we get? Oh, do you see that you're already dominating? You're already 1 cent ahead of this guy. You got it? And now it gets crazy. I only have the power to do this one more time, and you should understand the difference. Now I take 102.0. Now you're making interest on interest, and then you're taking 12% divided by 12. So take 1% of that and tack it on to 102.01. And now you want to get nuts? Let's get nuts. It's $103.03. Holy cow. You're already 3 cents ahead of this guy. Because at the end of 12 months, you at least have 112, but then you'll have pennies on the dollar on top of that. All right. So I want you to understand what this means then. So here's what he had. He gets 12%, but he gets it 12 times a year and 1/12 of those payments 12 times a year. That's why 12's in 2 spots in this formula. And I like people to know where the formula comes from so they understand what those components are, so then in the future they know where to put it. And we only had time for 1 year. So that's why that T right there, that would just be 1 right there. Okay? So his number right there would be ridiculous 12% per year, but paid monthly. So that's 12 payments of 1/12 of 12%. That's why 12 goes there and there. Got it? That should make total sense. All right, I'm done. I just want to at least explain the compound interest formula. Okay, that was fun. No, I'm serious. They don't help me at all. It's nothing. Just look at me like I'm some sort of weirdo, which may be true, but they don't have to at least tell me with their eyes that I'm a weirdo. It hurts my feelings.